So now let's get started. Today we have a very special topic for this StarRocks Roundtable. We're going to talk about 2024, all of the things we've been through, all of the features that's been released, and all of the new use cases that are there, right? And also going to talk about what's next in 2025, right? So in the near term, so what's going to be released for the version 3.4, we're going to give a short teaser for the 3.4 release, and we're going to give an outlook for the 2025 year, right? So now let's get started. So Happy New Year's, guys, first. Actually, I'm curious. So what is the last date that is acceptable to say Happy New Year to you guys? Actually, I don't know. I think it's by the end of January, but I don't know. Yeah. So, but now let's get started. So we have Harrison, who is this one of the StarRocks TSC member, and we also have Chelsea Wang on the call, who is an StarRocks active contributor. Okay, so I'll first hand the microphone to Chelsea. She's going to introduce go over what we've released in the year of 2024. Okay, so the stage is yours, Chelsea.
Hi, thank you. Can you see my screen? Okay. Hi everyone, I'm Chelsea. I'm an active contributor to StarRocks. Over the past year, StarRocks has upgraded to a Lakehouse architecture, and we continuously iterated through the version 3.1 to version 3.3, and we released nearly like 20 versions. And today, let's do some reviews of the progress in the last year. So the goal of StarRocks Lakehouse architecture is to provide users with the performance of data warehouses, but on an open data lake. So we know that data warehouses and data lakehouses are two commonly used architectures. And both of them, they have the distinct characteristics, and they have different suitable scenarios. For example, for the data warehouse, typically it can offer a better performance, a better latency, because their data formats are more structured. But on the other hand, their cost will be higher. And for the data lake, they are more suitable for the ad-hoc queries to do some data exploration and machine learning tasks, because they have better flexibility and better compatibility. But we do often suffer from the query latency on the data lake. So these two architectures coexist because they complement each other. However, this can lead to data redundancy, and the architecture will be way more too complex to maintain. So the StarRocks Lakehouse, we aim to bridge the gap. We want to provide a warehouse level query performance on a open data lake, but still remain the openness and the flexibility of the data lake. So how can StarRocks achieve this? This is the StarRocks Lakehouse architecture looks like. First, you can always query directly to the open data lake through the StarRocks by using a catalog. And if the query needs lower latency or higher concurrency, data can be ingested into the StarRocks by using external materialized view, or even the nested materialized views based on those materialized views. Since StarRocks is a OLAP system in the first place, so we can always benefit from the StarRocks efficient storage format to accelerate the queries. And those queries don't even need to be rewritten. StarRocks can take care of that. Our cost-based optimizer can handle the transparent acceleration. So in this way, we can achieve that queries that towards to the open lake can be seamlessly achieve the data warehouse-like query performance. And additionally, we can write back data to the data lake. So for example, for scenarios like real-time, because StarRocks, we do support real-time better. You can ingest the real-time data into StarRocks first to feed whatever your data application on top of it. And then after a while, you can write back all the data to the open data lake to achieve the single source of truth. So overall, in this picture, StarRocks acts like a unified layer to combine the data lakehouse experience and the data warehouse experience. So in the past year, we are aiming to achieve this. Let's highlight some key features to see how we achieve this goal. But for details, you can always check out the race notes, and there are meetups videos of version 3.2 and version 3.3. You can always check that. First, for the queries that directly towards the data lake, we do a bunch of improvements to accelerate their query performance. Because when you query a data lake, the data is not managed by StarRocks, right? We need to fetch all the metadata and the data that in external storage. So there will be a lot of optimizations during the process. So first, for the metadata optimization, in version 3.3, we introduced a distributed metadata plan for Iceberg and also a manifest cache for Iceberg. Also, there will be a smart strategy to choose which method to use based on your query's situation. And this optimization is also extended to the Delta Lake and the payment catalogs. And also, we support to collect the statistic to generate a better query plan. For data readers, we always keeps doing improvements like Apache, ORC, text file, and all the optimizations are derived from the real world scenarios. And also for data caching is also a performance booster in the direct query to the data lake, right? And in the past year, we support SLRU, we support the cache roadmap. You can pre-cache all the needed data in advance, and we support the adaptive I/O based on your disk's condition and so on. And also, thanks to the contributors, we've added many more connectors to enrich the whole ecosystem. And for the whole architecture, we can see in the picture that I showed before, Materialized view is a very critical feature in our Lakehouse solution. And when it comes to the lake queries, we realize that the lake table are often partitioned. Most of them are partitioned. So we add a bunch of optimizations for partition refresh and the partition mapping strategy between the lake table and the StarRocks table, the Materialized views table. And also the rewrite is a killer feature of Materialized views. That means that users don't need to modify their query when they use Materialized views to accelerate their queries, right? And except for the SPJG, the basic SPJG optimization, we introduced the text-based rewrite and the view-based rewrite in the past year. That will be super useful for scenarios like BI reporting or like matrix modeling scenarios. And also, during the past year, more and more users are creating lots of Materialized views in their production environment. So we optimized rewrite strategies to handle the larger scale, like hundreds of Materialized views in one StarRocks cluster. And also we improve the observability across the Materialized views lifecycle. And beyond this, we introduce a bunch of new capabilities and enhancement, like we support for the AWS Graviton. We do some enhancement on the semi-structured data, like we support the flat JSON, and we keep making everything simple. We keep simplify the table creation, the data ingestion, the fast schema evolution, make schema change more faster. And also there are a bunch of optimizations on the shared data structure. We provide a migration tool, and there are many optimizations on the primary key table. So there are far too many features to cover here. So if you are interested, I encourage you to explore the release note or the version release videos. And in the past year, we also welcomed even more users to the StarRocks community. For example, I know I know many of you may start to notice RedNote, the Xiaohongshu recently. They are actually the StarRocks earliest adopters. They use StarRocks like at the beginning of our first open source. By now, they are still one of the biggest community users of StarRocks. For example, their real-time advertisement reporting scenario, the one scenario now, it runs on more than like 30,000 cores of StarRocks cluster. So in 2023, they began to exploring new scenarios. First, they tried to replace their Ad-Hoc platform with StarRocks, and their result is remarkable: 6 to 7 times performance improvement and 90% reduction in P90 latency. That's very impressive. So the Lakehouse architecture began to win, and in 2024, they start to do other experiments, like can we replace the warehouse architecture with the Lakehouse architecture? So they start to replace their warehouse architecture using the Iceberg plus StarRocks. So the problem of the traditional warehouse architecture is they often require heavy data processing. So that will be a problem if the scenario is like self-service analytics, because that makes that in that scenario the logic of the business can change very often. So when a change in business logic happens, that demands significant resources for pipeline adjustment, not only in the machine, but also in the manpower. So with StarRocks Lakehouse architecture, first, they can directly query the Iceberg table, and we can do join and efficiently join. And so they can eliminate the pipeline complexity. And also, they can use StarRocks audit log to find the potential optimization of the Iceberg tables, and they can do the adjustment on a daily basis because there won't be any denormalization. So the adjustment will be much more easier. It won't need a lot of resource. So also they use the data cache warmup to fetch the data in advance. So with this approach, they achieved 3 times better performance than the traditional warehouse solution, and even reducing the storage cost. Another example is Shopee. They are a very well-known e-commerce platform in Southeast Asia. Of course, in their company, they will have a data warehouse architecture and a data lakehouse architecture. And the data warehouse solution, the data will be denormalized and ingested into the warehouse. And just like what RedNote does, it will be very difficult to adapt quickly when the business logic changes. And for the data lake solution, of course, they can query the data lake directly, but they often suffer from the query latency. and there will be different kind of solutions inside the company and make it very difficult to maintain. So with StarRocks, especially the external catalog and the materials view, first the query can be submitted directly toward the lake data. And when the concurrency and the latency cannot meet the requirement, then they create a materials view. So with the overall solution, their platform is unified, and they will gain like 2 to 10 times faster than the older solution. And now they are planning like 25,000 more cores in StarRocks cluster. And there are many more adopters of StarRocks in this year. I couldn't say thank you too much at Pinterest, Demandbase, Fanatics, and many other users. They have contributed very many outstanding use cases to the community, and we couldn't be more grateful. And hopefully we can have more users and contributors in the 20 and 25. Yeah, that's all I got here. Thank you.
Thank you. Thank you so much, Chelsea. Thank you. Guys, if you guys have any question, now would be the best time to ask, since the two guys are here. And yeah, so and we are going to have have time for to answer all of your questions at the end. So now let's welcome Harrison, StarRocks TSC member, to the stage to introduce StarRocks roadmap for the 2025 year. Also a small teaser for the 3.4 release. Okay, so welcome, Harrison. The stage is yours.
Okay. Thank you, Sida, and thank you, Chelsea, for sharing about so much inspiring things. And let me share screen. Okay. Yeah, I think I just have two topics here. The first one is a quick summary of the 3.4. It's very excited that we just announced the release of 3.4 earlier this week, but it's still a RC version. But I think we could release the official release at the end of this month, maybe. And here is some highlight for this version, and I just split it into 4 pillars. And first one is about some new scenario. We optimize StarRocks for some special scenario. The first scenario is the AI workload. More and more customers pay attention to the AI and BI together, and to make full use of the large language model. And vector search is definitely a very important feature in this pipeline. And actually, we introduced the vector search early 2023, and you can using a long chain, such things like the RAG pipeline, RAG framework, to using StarRocks as a vector storage. And but recently we finally introduced the vector index, and which can support HNSW and IVFPQ. I think these two are most popular index type in this area. And with this kind of two kind of index, we can accelerate the vector search maybe 10 or 100 times faster than before, because it can just scan the nearest neighbor search for the for few to a very limited record. So that's the first exciting feature. And beyond that, actually, StarRocks is a NC SQL database, and we can support all kinds of predicates filter. So you can also using filter predicates and the scalar predicates and the vector search together to achieve a hybrid search capability in this kind of index. So the second related AI workload is we introduce a new Python UDF. Previously, we only supported some Java UDF or C++, but the building function is not enough, and Python is the first tier citizen in the AI world. So you can using some AI Python UDF to introduce some other, no matter it's large language model inference or machine learning workload. You can introduce all kind of Python UDF into StarRocks. And the third part related to AI workload is the Aeroflight. It's another popular feature asked by many community users for a long time. And before that, as we know, StarRocks can using MySQL protocol to connect it to the client and the server, or we can using HTTP protocol to get some query. But both of them, HTTP protocol and the MySQL protocol, using role-based protocol, which means if we transfer a lot of data and we need to extract data row by row, and that may be much more slower than columnized, because StarRocks kernel is fully vectorized query engine and using column style to memorize, to organize the memory. So with the Aeroflight or ADBC, and we can get better performance than JDBC or HTTP protocol. And in this new protocol, the client just directly query to the backend or compute node. They needed to pass data through the front end, because that may become a bottleneck if we transfer a very large amount of data. Yeah. So with this kind of three feature, we can enablement AI workload much more better than before. Yeah, here's the first exciting feature. And the second scenario, I want to talk about some real-time scenario. And we also have two features related to this area. The first is merge commit. And I remember I talked this feature maybe a few months before, and to give maybe in next webinar we will give more hands-on demo about this. But generally speaking, the merge commit just can merge a lot of small transactions together. If, for example, if you have some high concurrency TPS scenario, the data ingesting very frequently, for example, 100 TPS, and we can't cover it before. But with you, if you enable this kind of merge commit, we will automatically to merge small transaction into a large one. You just set set a batch period. We will automatically to do that for stream load, and we also optimize for Flink connector to make it easy to use for merge commit. And synchronized materialized view is also a useful feature in StarRocks, and especially for some single table, some ads scenario. They have a very large number of data ingestion, high throughput data ingestion, and they need to build some roll up based on the aggregate table or base table or duplicate table, and we can using synchronized materialized view to accelerate them transparently. Recently, we supported it in shared data architecture. That means our shared data is more mature compared to previous version, and it catch up nearly all the feature we have supported in shared data. Yeah. The last part I want to emphasize is that we can support a sketch hyperlog log. Many customers come from Druid recently, and they really want to have a similar experience for the data deduplication. And Druid already supports the sketch hyperlog log. StarRocks previously just support old algorithm for hyperlog log, but the precision is not good enough. And currently, you can use all the data sketch algorithm in StarRocks. And beyond that, we don't only support this kind of data type, we can support a general aggregation function as a middle state. That means you can create a more general materialized view using this kind of pre-aggregate function, and that will be help to make our materialized view, especially for some incremental materialized view, easier. Yeah. The second part is about the data lake. Yeah. StarRocks focus on data lake and the Lakehouse for a long time, and first is about the Iceberg, and we can support the Iceberg branch and the tag now. And it's a very useful feature for many of our customers because you can, using data, you can build a data engineering pipeline like a software engineering. Data can also create a branch like a Git repository, and you can change some data and then merge into the main branch, things like that. And you can choose to set a timestamp or version to do some time travel things to select some snapshot of the data. And for data lake, we recently supported the column mapping and delete vector. And these two feature is more and more popular in data lake customers because it's generally become default option for most of the latest data lake tables. So the column mapping, if you do some generated column, it will enable by default. And for delete vector, if you have some data level table or things like that, it will be enabled using a lot. So we can support to query directly all of this. And the last part for data lake is we introduce a SLRU algorithm. And as we know, SLRU is a specialized LRU algorithm. S means segment here, and we can split the data cache into two segments. It's one for a special segment, and another is a normal segment. We always face a scenario that's a large query. When a really large query comes, it may be flush the all data cache, and that will influence other query latency a lot. So with this kind of new segmented LRU, the large query just flush the basic segment, and the protected segment for the hot data won't be flushed. So it can reduce the pollution caused by occasional large query and improve cache hit rates. And finally, we can minimize the query performance fluctuation. The next part is we always optimize StarRocks performance continuously. And actually, we don't talk about TPC-DS for a long time because we focus on some real world more. But customers always like to play StarRocks starting from a typical benchmark such as TPC-DS. Recently, we found more common optimization for TPC-DS. It's not a special optimizer for TPC-DS only. We find after the investigation, we found some, for example, runtime filter push down. It can push down to the scan layer, not only it can to the scan layer. It can filter more data before the materialization. And the second, maybe we can we also do some CTE reuse and some statistics on data lake. And for example, we can support foreign key and primary key for data lake for Iceberg, like internal tables. So we can also achieve some improvement in this kind of thing. And the next improvement for performance is a query feedback. It's a very interesting feature because in the real world scenario, the planner can't predict everything. This always still have some corner case. So, for example, maybe statistics not collected well, or maybe the data have some skew. We can't predict it good. The left table and the right table may be wrong. Well, so the query feedback can get the bad plan and put it into the advisor, a plan advisor, and it can save the bad plan. And next time you run the same query, it will using the bad plan and to choose the best query plan for that. So this kind of feedback will be make it more optimistic and atomically to optimize the query performance. Yeah, the latest part is asynchronous plan and scan range. For this case, is optimized for data lake also, and because for some data lake query, we have really large query. It may be query a large a lot of files, and previously we need to scan all the file list into FE and then generate the query plan to send to all the BECN. But with this asynchronous plan, we can dispatch the query plan earlier than we get all the metadata, and it can reduce the query memory. Also, it can be optimized a lot of simple query. For example, select star from a table, limit 100 or 10. It in some our benchmark, and it can accelerate 2 to 5 times faster than before. It's really amazing using this capability. And the last part is we still improved our ease of use for StarRocks tables. And the first one is we want to make the table creation, the data ingestion, and the data refill easier than before. And we have these three features. The first one is we have introduced a unified partition, and previously we have a lot of partition method, actually list partition, range partition, or the dynamic partition, and we finally merge all of them together. The new customers, you can just using the partition, the expressional partition, and it can support multi-level expressional partition now, and you needn't to using other partition method. It will be more easier for newcomers. And for the data insert, we enhanced the insert from files a lot, and it can support some. It can support not only by positional data ingestion, and also can support by name, and improve some performance about the files. It can totally replace the workload now. Yeah, you can just using everything to insert is more intuitive than Workload. You can using it freely. And the latest part is for dynamic override. If you have familiar with Hive or Spark, they also have this kind of capability. When we do a large data refill, and it can maybe some partition we need to do the data replacement, or some partition we need to create a new partition. And with this dynamic override, we can use one statement to insert override to implement all. So that's where make our life easier. So here is the general introduction to the 3.4, and I think we have more for some graceful exit and some other feature I haven't mentioned. I think next time we will have another webinar to dive deep into this kind of features. So yeah, here is the gift, I think, at the beginning of the year for the community. And okay. And the next part, I want to talk about the StarRocks 2025 roadmap forward. Actually, we still discussing this roadmap. I haven't created the GitHub issue now. Maybe I can implement it at the end of this month. And so in this webinar, I just show you some guideline and the top priority in my mind. So I choose the StarRocks have a lot of more and more function, but we still need to focus on the most important thing for our customers. I just listed these two as the top priority topic. The first is we still want StarRocks to be the best choice for customer-facing analytics. And customer-facing analytics, maybe you have not familiar. It's just because our customers put analytics to their customers. Maybe it's a SaaS company, or it's a gaming company, or AIDS company. They want everyone to know about the data and the insights of the data. So this kind of analytics is different from some internal reports, because they are more important in very serious scenario. So they have higher SLA requirements and low latency requirement. I put this, I named this features as like a query resilience, which means customers, when we do building a customer facing analytics, we need a low latency with as high SLA. And no matter the workload changes, the query plan changes, or the node failure, AZ failure, all kind of things, we need to keep the resilient to all kind of unexpected behavior. So that's the most the biggest differentiator with other analytics. So StarRocks, we are focused. StarRocks is really good at this kind of scenario, actually, but we still want to make it more and more stable and resilient in this kind of scenario. For example, I can take a few recent projects and to around this feature. For example, we introduced a new query plan manager, and it can make your query plan stable, because statistics can be changed, data changed, and we don't want to optimize the query, make some performance degradation, and maybe new data come, maybe a new partition changed, and maybe you upgrade the StarRocks to a new version, because StarRocks, we optimize performance and introduce more and more performance improvement, but we can't, they still, maybe some improvement, even we test very tensely around this feature, they still have a few corner cases. We want to, even you upgrade or data changes, we the query plan manager can keep it stable, and it will catch some important and the existing performance, existing query plan, and to use the best query plan, and to avoid some performance degradation. And another project around the workload management is similar. Maybe you have a lot of, we have a lot of feature around this, for example, resource group to do some isolation between different workloads, but it's not good enough because in some scenario, it's not easy to identify what kind of workload is a large query or small query. We need to do more around this to make it automatically to manage a different kind of workload, and to do the better isolation around this. For example, we introduced some hard limit for resource group recently, and we are introducing more intelligent classifier to classify different workload. And also customers want to get better and quickly performance, the large query positioning method. Yeah, we're also working on that. And yeah, that's it. The second challenge for customer facing is that multi-tenant management, because when we develop a customer facing analytics to your customers, so each company have a lot of customers, and for different talents they have different SLA, so they need a better partition method to do the data maintenance, to do the partition replacement, or resource isolation, or even some fine granularity privileges around this. Actually, this way we StarRocks have done a lot of things around this before, and yeah, it's pretty good now in my mind. And the next part is to simplify the pipeline. As Chelsea told that we do a lot of optimization for Materialized view, and Materialized view can, and StarRocks has pretty good join performance, which can lead the less denormalization and less data ingestion from the data lake. We can use in Materialized view to connect the data lake and the StarRocks internal table, or StarRocks together, and you need to care about how to do the data re-ingestion. And we also to try to unify all the data type and the data ingestion method, make them easy to learn and optimize. Yeah, the last, and I think it's the most important things, we want to make our shared data architecture as a default choice. And actually, shared data architecture released more than nearly 2 years, yeah, from 3.0, and I think in 2025 we can make it as a default choice in this kind. For example, the shared data can achieve much lower cost, and it's more cost effective than share nothing, because it just need one replica in data cache, in local cache, and all the data stored in S3 or other object store. And but if we want to using shared data as a customer facing analytical scenario, customers still have some concern about that. What about the cache misses? What about node failure? Maybe we can achieve high availability in shared data architecture before because all the data stored in the S3. But if one node failure, the cache misses will influence a lot about the P19 or P99 latency. They can't achieve the latency SLA. So we are working on some computer replica to make it more stable and make it more mature for this kind of scenario. So yeah, in total, just we will work a lot or continuously working on this scenario to make StarRocks is the best and most cost effective in customer facing analytics scenario. Yeah, that's the first point. And the second point, I think we also talk it a lot, is to make StarRocks and the best Lakehouse solution. And we have a lot of lake format before, but recently Iceberg is become more and more accepted by many. It's nearly won the table format war. But another point is that Iceberg and other table format, no matter it's Hoodie, Delta Lake, or even Payment, they have more and more interoperability tools to make them the same, actually, or similar. Iceberg catch up other data lake formats a lot, and we can see that they have Iceberg v3 specification, introduce some delete vector, variant, and geotype. That's very exciting. We are surely to catch up this kind of feature as the first time. And the most important, the most brilliant part for StarRocks is I think we are already the best query engine on data lake. We optimize a lot for statistics, indexes, and also materialized view, but we will continue working on that. For example, we considering about to introduce incremental materialized view for Iceberg, and that will make the even some previously we can support a partition level incremental materialized view refreshing, but we considering more and more customers using near real-time pipeline in Iceberg or other data lake, and it can we will to introduce as a query engine. Materialized view is the most important method to accelerate query, and the incremental materialized view refresh can reduce the refreshing cost to a very low level. Yeah, and you needn't to introduce any other pipeline maintenance effort. You can achieve lower cost to the data materialized view refreshing. And the next part is StarRocks. In the 2025, we want to fully support all the operation for Iceberg, not only for query, but also for DDL, DML procedures, or table migration. For example, still we saw that still a lot of customers using Hive table or GNU table without Iceberg. They have some concern. For example, the data migration have a lot of effort. If we can, we will contribute more to make it easy to happen to migrate from other table to Iceberg table. And the last part is we were considering to add a compaction service and or even some auto layer arrangement for Iceberg. Maybe it's similar to liquid clustering in Delta Lake, and because if we want to achieve the best performance, we can't to do the we can't only implement in engine side. We still need to optimize the layout, the sort key, the indexes. But if we know the query pattern, the SQL, and we can optimize the data for the best layout, and not only compact the small files into a larger one, but we can also to do some reordering to make it more faster for the query pattern. Yeah, that's it for all our plan. Yeah. Thank you, everyone. And Sida, any question or we can continue?
Okay, so looks like we do have a few questions here. Wait, let me get the questions out. So first question, when will Aeroflight be available?
Aerofly is in 3.4, but in RC version, it's not ready. Actually, maybe in February, the official version of 3.4, 3.4, 3.40, I think maybe 3.4.1 can be available. Yeah.
Okay, so also, yeah, go ahead. Sorry.
Oh, I'm done.
Oh.
Yeah.
Oh, I thought you said something. Sorry. Yeah. So, and we actually we do have a webinar in early February. That's yet to be announced, but we're gonna announce it soon. That's dedicated to version 3.4, where I will dive a lot deeper into all the features and use cases and whatnot. Yeah. So
yeah, I think we can give some demo or hands-on demo for this kind of feature if you are really interested in this.
Yeah, and that's gonna be a lot of fun. So keep an eye on for that, and definitely attend. And we have another question. So, is there any plan to implement MySQL-style store procedures and user-defined triggers?
Okay, actually, yeah, maybe I can talk a little bit about this. And first, I think MySQL-style store procedure may be not easy because it's still defined for a TP system, not an AD system. But currently, we implement some early version of the multi-statement transaction, and yeah, you can actually you can using in maybe it's still in main branch 2.5, I think, and you can do a multi-statement transaction for insert into different table or insert into same table. You can using that, and but we still need to improve the some merge into or update things to make it available for multi-statement multi-statement transaction. Yeah, we will consider that, but it still seems a long way to go. Yeah, because for even for I think for data lake, especially for data lake or Iceberg, they don't have that fully support for multi-statement transaction because it will involve a lot of component to implement that, maybe catalog service, maybe a query engine and the table format. We need to discuss the spec about that. For StarRocks internal, and we also have some challenge for our storage layer. We need to improve to our storage layer to resolve some conflict when we do long transaction. Yeah, and the user-defined trigger, maybe some kind of trigger can implement can transform to a materialized view, but yeah, it depends what kind of scenario do you want to use user-defined trigger. Yeah, if they maybe our community is working on something like the make StarRocks have a bin log connect to Flink, and Flink can consume the incremental changes for StarRocks and to do some streaming thing. Yeah, if you're using StarRocks internal engine to do the transformation, incremental transformation, we can make a materialized view. We want to improve materialized view to implement that. Yeah.
Okay, thank you, Harrison, for the answer. And we have another question here. are there any thoughts on supporting AWS Kinesis for streaming ingest? I think Harrison.
Yeah, I'm willing to hear this kind of requirement, but for Kinesis, we just using Kinesis previously have a KDA, right? Kinesis Data Analyst is a managed Flink, and recently they moved this product to fully managed Flink service in AWS. You can using that to do the data ingestion and to do the streaming ingestion, and you can also use in Kafka or to consume from that, but we can't. StarRocks can't directly consume from the Kinesis now, basically. Yeah.
Okay. Yeah. So if there is a tool that you really love but StarRocks doesn't support, just shout as loud as you can, and the community is gonna take care of the rest. Okay. And is there any other question? Oh, let's give it another, let's say, 20 more seconds. If there's no more question, we're gonna call it a day. Any other question? Today will be probably the best day to ask your StarRocks related questions. Let's give it 10 more. Okay, I think that's it for today. Thank you everyone for joining, and thank you Chelsea and Harrison for the really exciting talks. Thank you everyone so much. Thank you, and see you guys again next time. Thanks.
See you.
Okay.